All right, so for example 2, we're asked to solve for x. We have a quadratic equation in this case, x squared plus a 3x minus 28 equals 0. One of the methods that we're going to go ahead and use to solve for x is that we're going to go ahead and factor. Now, before we factor, I do want to go ahead and express our quadratic equation, the general formula, which would be ax squared plus a bx plus a c. And in this case, we need to identify a, b, and c in order for us to factor. So our goal in this case, once again, like I mentioned, we need to identify a, b, and c. A in this case represents the leading coefficient. If you take a look, there's actually no number there, but there technically is. It's imaginary. It's actually an imaginary 1. So our leading coefficient here is a 1. Our b value in this case is actually the coefficient in front of the x, which in this case would be a 3. And our c value is the constant, the number that has no variable. Now that we have a, b, and c labeled, we could go ahead and draw our diamond. Now in our diamond, guys, we have on the top of the diamond, we have the product of a times c, and on the bottom we have our b value. So then in this case, if we were to multiply a times a c, we get a negative 28. And our b value in this case is 3. So from here, we want to go ahead and identify two numbers. We want to go ahead and actually identify two factors that multiply to negative 28 but add up to a 3. And if we think about the factors of negative 28, we have 7 and 4. In this case, the 4 will be a negative. So this is 7 and negative 4. Or it could be the other way around. It's the same thing. Now, in this case, guys, we have a leading coefficient of 1. Having a leading coefficient of 1 doesn't basically tells us that we don't need to do grouping. We don't need to do anything else. We're basically done in the factoring portion. So what I'm going to do next is now I'm going to go ahead and write my binomials. And we have the following. X plus a 7 and x minus a 4. And once again, we're rewriting the original quadratic expression, so I'm going to go ahead and make this equal to 0. Now, in order for us to solve for x from here, we have to make each of the binomial expressions equal to 0. So we have the following. Or x minus 4 equals 0. So starting off with the left-hand side, subtract 7 to both sides. We have x equal to a negative 7. Add 4 to both sides. And we have x equal to a positive 4. So in this case, guys, these would be our value for the zeros of the function, or the value for the x.